Hello everybody, today I can write sequences explicitly using an equals a1 plus n minus 1z and an equals a1r to the n minus 1. So there are two different formulas for writing the equation of sequences. One is for what we call arithmetic and the other is for what we call geometric. Arithmetic is when you are adding a common difference, and geometric is when you're multiplying by a common ratio. So arithmetic is when you're adding a common difference, and geometric is when you are multiplying a common ratio. So for arithmetic, an equals a1 plus n minus 1z. And for geometric, it's an equals a1 r to the n minus 1. Now let's talk about what each of these variables represents. So for both of them, a of n is the nth term, a1 is the first term, n is the term you're finding, that applies to both formulas. Now d is the common difference. It's what you're adding to get from one term to the next. Sometimes it's common sense, but if it's not common sense, to find the common difference, it's the second term minus the first term. R is the common ratio. And again, sometimes it may be common sense, but if it's not, the common ratio is the second term divided by the first term. So we did a lot of talking. Now let's do some doing. Number one, write an equation for the following sequence and use the equation to find the 10th term. So the first thing I have to determine is if this is arithmetic or geometric. Is the pattern adding or is the pattern multiplying? Well, most of you can probably figure this out just looking at it. What would I have to add to -1 to get to 3? I would add 4. What would I have to add to 3 to get 7? I would add 4. What would I add from 7 to get 11? I would add 4. It's the same thing. That's my pattern. It's arithmetic because I'm adding. Now, let's just say that you couldn't figure that out, or there were bigger numbers and it wasn't as obvious. What I can do is I can go to my calculator and I can do the second term minus the first term. I can do the third term minus the second term. I can do the fourth term minus the third term. And if I'm getting the same thing every time, well, that means that it's arithmetic, and that means that in this case the common difference is 4. So I write down the formula for arithmetic. Now these formulas are given to you on the reference sheet, so you do not have to have them memorized. But here they are. You might want to take a picture of them or write them down, or refer to your reference sheet. An equals a1 plus n minus 1z. So an is what you're finding, or an is an. A1 is the first term, which is -1. N minus 1 stays n minus 1 when we're writing the equation for the sequence, and d is 4. So this would be an equation to represent the sequence. Now, if this is a question on an exam and it's multiple choice, you might see your answer like that, or you might see it in, mx plus b or standard form. So if I wanted to put it into an equivalent form, I'll do that in green here. An equals -1 plus n minus 1 times 4. I would distribute the 4 and combine like terms, and I would get this. So either of these answers are fine if it's open response, but if it's multiple choice, you might see them either way. Now, just a little heads up. So this is what we call subscript notation, sequence notation. It's a little subscript. It's a little like, it's a little kind of like log base where it's written at the bottom. It's just a little subscript, and the subscript refers to which term we're finding. So now, if I want the 10th term, the whole point of this equation that I just created is I can use this to find whatever term I want. So if I want the 10th term, that's A10, I'm replacing the n with 10. It's easier to use this version than this version, although you can use either one. And A of 10 would be 33. So the equation is either the blue or the green. Either one is fine. They're equivalent. If it's multiple choice, you might see either one. And then once you have the equation, if I want to find a specific term, then I'm going to just substitute that, whatever term I want to find in, for n and get my answer. Number 2, I have to find the pattern. I have to see if I'm adding or if I'm multiplying. So 19 plus what is 16? -3. 16 plus what is 13? -3. 13 plus, I don't know why I wrote -13. 13 plus what is -10? -3. My pattern is -3, which means my D is -3. If you couldn't do that mentally, then you can just do the second term minus the first term. 16 minus 19. (13 minus 16). 10 minus 13. Since they all subtract to the same value, it's arithmetic, and the common difference is -3. So, since it's arithmetic, since I'm adding, an equals a1 plus n minus 1z. An equals a1 is the first term, that's 19. N minus 1 stays n minus 1. D is -3. Whenever D is negative, I like to put it in parentheses. Otherwise, it looks like a -3. And that's it. That's your answer. However, if it's multiple choice, you might see it in quote-unquote slope-intercept form. So if that were the case, to get that into slope-intercept form, I would distribute. Don't forget to distribute the negative, -3n plus 3. Combine like terms, -3n plus 22. Now it wants me to find the 10th term. So to find the 10th term, I replace n with 10. The point is, once I have an equation for the sequence, I can find whatever term I want. And that is -30 plus 22. You can use a calculator if you need to. That's -8. So find the pattern. If you can't determine the pattern mentally, you can use your calculator, subtract, 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 see if they subtract to the same thing. They all subtracted to -3. So that is your common difference. Once you recognize that it's arithmetic, we use the arithmetic formula, which is given to you on your reference sheet and at the beginning of this presentation, and you substitute it in from there. All right. So, number 3, again, we're going to see if we can do this mentally. So here's the thought process I go through. What am I adding to? I always try addition first. What am I adding to 2 to get 8? I'm adding 6. What am I adding to 8 to get 32? I'm adding 24. What am I adding to 32 to get 128? That's like 96. Am I adding the same thing? No. So it's not arithmetic, because if it was arithmetic, it would be the same value. Essentially, arithmetic is linear, and geometric is exponential. So now I'm going to try multiplication. What am I multiplying 2 by to get to 8? 4. What am I multiplying 8 by to get to 32? 4. What am I multiplying 32 by to get to 128? 4. There's my pattern. It's times 4. So the common ratio is 4. It's geometric. I write my geometric formula, which is different than my arithmetic formula, which is that right there. Now again, let's say that you can't do it mentally. Then I always start with subtraction. I'm going to subtract the second term and the first term, the third term and the second term, then 128 minus 32. Do they subtract to the same thing? No, so it's not arithmetic. Now I'm going to try dividing the second term by the first term, dividing the third term by the second term, dividing the fourth term by the third term. Do those all divide to the same thing? Yes, that makes it geometric, that makes the common ratio 4. So, an equals a1, the first term is 2, r is 4 because that's what I'm multiplying by, and then n minus 1, just like the other formula, stays as n minus 1. Now, unlike the other formula, I'm done. If it's geometric, I can't do anything. I can't multiply the 2 and the 4 because the 4 is attached to the n minus 1. So there's absolutely zero algebra that you need to do for the geometric formula. Now, if I want the 10th term, same thing. I'm going to replace n with 10. Understand that since geometric is exponential, it's going to get really big. So don't be surprised if you get a really big number. So 2 times 4 to the power of 10 minus 1. 524, 288. And that's your answer. So I had to determine the pattern. I tried addition first. It was not adding a constant amount, so I tried multiplication. Yes, it was multiplication by 4. And again, if you aren't good with doing that mentally, you could always use your calculator. Subtract the consecutive terms. Then that didn't work. Then divide the consecutive terms. That worked. That makes it geometric. That makes the common ratio 4. So I go to my reference sheet. I write down the geometric formula. I substitute into it. If I want the 10th term, once I have that, I just replace the n's with 10s, and I get my answer. I want you to take about 20 seconds, and I want you to determine if this one is arithmetic or geometric. No need to pause. I will pause. I will just sit here for about 10 or 15 seconds while you determine whether this one's arithmetic or geometric. Arithmetic, you're adding a common difference, and geometric, you're multiplying a common ratio. The pattern here is plus 6, plus 6, plus 6. If you couldn't do that mentally, then you do, I always try arithmetic first. So you would do negative 503 minus negative 509. I would do negative 497 minus negative 503. I would do negative 491 minus negative 497. They all subtract to the same thing. That makes it arithmetic. That makes the common difference 6. I want you to try and finish the problem. Well, let's write the formula first. So we go to our reference sheet, we write down the formula. AN equals A1 plus N minus 1 Z. I want you to pause it. I want you to create the equation and then use that equation to find the 10th term. So please pause, try the problem on your own, and then unpause. Now that you tried it on your own, A1 is the first term, negative 509. N minus 1 stays N minus 1. D is 6. That's fine, but if you want to put it into the other form, the slope-intercept form, I would distribute 6n minus 6. I would then combine like terms. You can use the calculator if you need to. And that would also be your answer. Either one is fine. If this was a quiz, either one would be fine. If it's multiple choice, though, you may see either one there. Now, to find the 10th term, I'm going to replace n with 10. So I'm going to do A10 equals 6 times 10 minus 515. I think I know what that is. I think that is, I don't know, it's giving me a little bit of a headache. Negative 455, I think. But let's just use the calculator to be sure. I'm kind of tired. I don't want to let my tiredness cause me to get this question wrong. 6 times 10 minus 515, negative 455. And that's it. All right, let's take a look at number 5. I want you to take about 10 seconds, 15 seconds, 20 seconds. I want you to determine if it's arithmetic or geometric. And if so, what the common difference or common ratio is. So I'll just sit here for about 10 or 15 seconds, decide if it's arithmetic or geometric, if you're adding or if you're multiplying. Okay, so again, I like to start by trying addition. If I'm trying addition, then I'm adding negative 15, then I'm adding 30, then I'm adding negative 60. That is obviously not giving me a common difference, so it's not arithmetic. So what do I have to multiply 5 by to get to negative 10? Negative 2, negative 10 times negative 2 is 20, 20 times negative 2 is 40, negative 40 times negative 2 is 80. There it is. My common ratio is negative 2. It's geometric. So now that I have that, I want you to pause it, complete the problem, and again, that's the geometric formula that's given to you, and then unpause. So pause, complete the problem, unpause. Now that you completed the problem on your own, I will go over it. A1 is 5, R is negative 2, n minus 1 stays n minus 1. For geometric, there's nothing algebraically to do. You're done. Now, the follow-up question, it wants the 15th term, so I'm going to replace n with 15. This is going to be a very big number. Whenever it's geometric, again, geometric is essentially exponential. So it's positive 5, negative 2 to the power of 15 minus 1. You might be thinking, Mr. Shalansky, can I just, like, instead of 15 minus 1, write 14? Yeah, that's fine, either way. 81,920. That's it. So there's just one more thing I want to take a quick look at. Something like number, nope, yep, maybe, Where is it? Is there one like it? No. All right. So, you know what? I just want to very quickly, what if, I'm surprised I didn't give an example like this, but what if I had something like 64, 32, 16, 8? So, am I adding the same amount? No. Am I multiplying by the same amount? Well, some of you are saying, well, we're cutting it in half. We're dividing by 2. The common ratio is not what you're dividing by, it's what you're multiplying by. So if I'm dividing by 2, that means I'm multiplying by a half. Now, again, if you can't do that mentally, you can always just go to your calculator and do the second term divided by the first term. The third term divided by the second term, the fourth term divided by the third term, and it's going to give you 0.5 or a half. So if you're dividing, it's not what you're dividing by, it's what you're multiplying by for geometric, and it's what you're adding if it's arithmetic. If you're subtracting, you're adding a negative. B would be negative. If you're dividing, you're multiplying by a fraction, R is going to be a fraction. Your classwork/homework is to finish writing sequences explicitly. Again, there's 2 types. There's arithmetic when you're adding. There's geometric when you're multiplying. If you can't figure it out mentally, then use the calculator. Subtract, subtract, subtract. Divide, divide, divide. Whichever method gives you the same value, that's the type of sequence it is. They each have their own formula. They're both given to you on your reference sheet, so you don't have to have them memorized. Once you pick your appropriate formula, substitute the values in, and then once you have your formula, you have your equation, if you want to find a specific term, you can just replace that in for n. Have a great day, have a productive day, and I will be back soon.